concentration cells. So another way we can use the Nernst equation to determine not only a non-standard cell, but we could actually use the Nernst equation to determine an unknown concentration. So I'll set up an example for you, okay? Suppose we have both this silver reaction going in both the cathode and the anode. Well, if they were both at the same concentration, nothing would happen, okay? However, if one of them is much less in concentration than the other, then the one with the lower concentration, so I'll say LC and HC, so the one with the low concentration will serve as an anode, and that's due to what we call a chemical gradient. So the electrons are going to want to flow to the higher concentration silver because there's more of these silvers on this side to suck up those electrons, okay? So now what that means is we have this silver reaction as our anode. We have the same silver reaction as our cathode. But now we have to recognize that this would be my silver, and I'll say LC, low concentration. And this would, and I should put that onto the aqueous part. Okay, so that silver plus would be my low concentration silver at the anode. And this would be my high concentration silver at the cathode. And if I were to recombine these to make an equilibrium expression out of this, then my Q value, so the way that this is going to work, right, when I go to combine these, I'll write silver plus HC plus electron makes silver solid. And then this one, I'll write silver solid goes to silver plus LC, the low concentration, plus electron. And of course, when I recombine these, the electrons cancel and then the silvers cancel, and it just looks like it's silver plus high concentration goes to silver plus low concentration. And what's important about that is, once again, this is an equilibrium situation. I can get a Q out of this, and that's going to be, products over reactants. So that's going to be, I'll just write the low concentration side divided by the high concentration side, okay? And if I were to put this all together in the Nernst equation, right, so that's going to be E cell equals E cell standard minus the 0.0592 volts over the number of moles of electrons transferred, and then times the log of the low concentration divided by the high concentration. So what do we get out of this? Well, suppose this is unknown. Okay, so we'll say suppose unknown. And then, of course, we'd also have to suppose that it's less than our standard 1 molar value, okay? But all the same, we can imagine if, let's say, we wanted to measure the silver concentration maybe in our tap water, right? Or maybe we wanted to measure silver concentration after doing group 1 qualitative analysis, right? We wanted to measure some sparingly small silver concentration in our beaker. Well, what's kind of cool, right? We can see we've got a Nernst equation set up here. So our standard cell potential for this will be 0 because it'll all cancel out. Okay, so that goes to 0, which means then we can measure this. So we could measure the actual cell potential. So that means in this line right here, we would say, measure, put a voltmeter right there. We know the number of moles of electrons transferred in this system is 1. We know that this is 1.0 molar. So then that means quite simply, just by measuring the cell potential, we could determine the unknown concentration. And that is what we would call quantitative analysis, okay? And so this is quite common in quantitative analysis. We set up various electrodes for things you want to measure. So if you want to measure silver, like an unknown silver concentration, make a silver electrode. If you want to measure an unknown, let's say lead concentration, make a lead electrode, and so on. Okay, and we could even get really complicated with this and add like, a silver chloride electrode or the standard hydrogen electrode. All the same, we can use these cells more than just like measuring some cell potential. We can use that cell potential to actually determine an unknown concentration, which is pretty cool. And that's the game that's played in quantitative analysis. The chemistry majors out there, you'll experience this in the upper division coursework. Okay, so that's all I wanted to say about concentration cells. I'll see you in the next video.